I'm Arya.
And I'm Gabe.
In this video, our goal is to explain and determine the buoyant force acting on the ping pong ball caused by the water.
There will also be three forces that will be involved to find the acceleration of the ping pong ball, and they are 1. The applied force,
2. The gravitational force. 3. The buoyant force. In the end of the video, we will discuss the acceleration of the ping pong ball through the forces.
Secondly, we now want to calculate the buoyant force. In order to do this, we first need the volume of the ping pong ball because this is also the volume of the water being displaced. This is Archimedes' principle.
The volume of the sphere would represent the volume of the water being displaced. Therefore, we can use the volume of the sphere equation. We measure the radius to be 2 centimeters. The volume of the water displaced is 3.35 times 10 to the power of negative 5 meters cubed.
After we get the volume of the water displaced, we can now find the mass of the water. To do this, we can use the formula density equals mass over volume. The density of the water is 1,000 kilograms per meter cubed.
Now we calculate the mass of the water displaced. We rearrange the equation density equals mass over volume to find the mass. The mass calculated is 0.033 kilograms.
To find the buoyant force, we once again use Newton's third law. Buoyant force equals mass of the water displaced times gravity. The buoyant force equals 0.323 newtons.
Now we need the force of gravity on the ping pong ball. To calculate this, we need the mass of the ping pong ball and the gravitational acceleration. The mass of the ping pong ball is 2.7 grams, and the acceleration is, of course, 9.81 meters per second squared.
We then use Newton's second law, force equals mass times acceleration, to calculate the force of gravity on the ball. In this case, the mass is the mass of the ping pong ball, and the acceleration is the acceleration due to gravity. We have calculated the force of gravity to be 0.265 newtons.
For event 1, the ball is stationary, therefore the net force is 0. There are 3 forces in this event. There are 2 forces downwards, the applied force and the force of gravity on the ball. The upward force is the buoyant force.
We can finally find the applied force by rearranging the equation. The applied force is therefore 0.058 newtons downward.
At event 2, the ball is released. The ball will have an upwards net force. The buoyant force is upwards and the gravitational force is downwards.
This shows the acceleration.
We can now find the acceleration of the ball by dividing the net force by the mass of the ball.
The acceleration is 2.148 meters per second squared.
In conclusion, the buoyant force is 0.323 newtons upwards, and once the ball is released, the acceleration is 2.148 meters per second squared upwards.